How's it going, everybody? Happy Wednesday. It's Wednesday Friends Day. I'm rocking my best friend's shirt that I made. I also gave one to my best friend about one of our favorite songs and bands that we love. Today, I hope that you check in with a friend. How are they doing during this whole crazy time? Maybe even check with them on the math problem that is due and see if you got the same answer. Get some help. Otherwise, ask me a question. Today is pretty exciting for me because I'm going to check in with a friend. We have a guest speaker today. We're going to be graphing equations. We used Desmos on the previous video and it just popped up our graphs for us, but there is no Desmos when we go to take a quiz. So how are we going to write our answer? How are we going to show that graph? What are some key points? So we're going to take a look at this question and we're going to go to my friend and maybe a former teacher of yours. Here's Mr. Largent.
Well, now that I'm done watching Tiger King for the 5th time, I really feel like I should broaden my horizons a little bit. Wish I had a math problem to do. Hey Z, what's up, man? It's funny you called. I was just thinking about math. I know, right? Crazy. I know. I'm kind of bored, so do you have any math problems I could, give a shot at? I mean, I still use math every day. I mean, especially when I'm adding up all the copies of my book that I've sold. Yeah, I know. Unfortunately, I don't even need a calculator for that. Oh, okay, yeah. Do I have a pen and paper handy? Absolutely, I do. I always have my math materials ready to go. I mean, I just sit here with them at any given moment, just waiting, hoping that I'll have a problem to figure out. Y equals, All right, let me jot that down. Y equals, and then the parenthesis thing. Yeah, I think I know what that is. X minus 1, another parentheses, times x minus 3, then another parentheses. I think you're at my limit of parentheses. And then x plus 2. Yeah, I wrote it down. I'm going to give this a shot. Yeah, I'm going to see what I can do. So we meet again. Y, you crazy bugger, you. And x. Always putting yourself out there. Well, if I remember correctly, I want to substitute values. So basically, I can figure out on a graph where they intersect. So if I was substituting values for x here, basically it would be 3 times 2, which would equal 6. So that tells me that y equals 6. So that means that 2, 3, 4, 5, 6. So that tells me that's where the line is going to intercept on the y-axis. Hopefully that's right. And then I know based off of these that it's like the opposite if I remember correctly. So 1 would be a spot here. Then another line, then 3, and then on this side, that's where we would have 2. So 1, 2. So the line would go like this. Up, and then down, and then up, maybe?
So Mr. Largent did a fantastic job. His graph looked phenomenal. He wasn't perfect, but he definitely would have gotten an A. So I'm going to go ahead and go through some of his thinking and see how we can adjust that and maybe make it a little bit simpler. So I know he drew like some arrow down here and said that this was like a 6. And he is correct. His reasoning was a little bit off though. So what he was thinking about, he said something about a 3 times a 2. We do have to pay attention to the negatives there. I think he should have done -1 times -3, which is positive 3, and then 3 times 2, which is 6. Here's what Largent was really doing. He's really saying, like, let me find a point on the table. So let me find a point on the graph. One of the easiest things you can do is just plug things in. Like, let's just plug in 0. And what happens when you plug in 0? 0 minus 1 is negative 1. When you plug in 0, 0 minus 3 is negative 3. And when you plug in 0, 0 plus 2 is 2. So now if you multiply these numbers, now this is where his thinking comes into play. Negative 1 times negative 3 is 3. 3 times 2 is 6. So 0, 6 is one of the key points. In fact, it's our y-intercept. And Mr. Largent referenced that. He said that exactly correct. 1, 2, 3, 4, 5, 6 is where it intercepts, where it intersects the y-axis. So totally correct with that. Now he also mentioned something about doing the opposites in the parentheses, and you know we talked about that early on in the year when we factored, when we did parabola graphs, when we talked about graph transformations left and right. And yeah, totally correct. If we think the opposite of all these are key points, right? So we have x minus 1. 1 is going to be a key point. Now really, the key point is 1, 0, and let's talk about why. If you plug in 1, it's going to give you, actually let's write it out. If you plug in 1, it's going to give you 0. If you plug in 1, it's going to give you negative 2. And if you plug in 1, it's going to give you 3. But the key is that first group. If you can think 0, think how do you get to 0? 0 times anything is going to be 0 times anything is going to be 0. So as long as we can find the opposite, or we think 0 in one of these, if we plug in 1, it's going to give us 0, and 0 times all those is going to end up 0. So we plug in 1, we're going to get a 0, right? Now we can do that a little bit quicker, a little bit shorter, a little bit faster when we go here. When we plug in 3, we're going to get 0. When we plug in 3, we're going to get 0. What I should technically be showing is this as well. Plug in 3, plug in 3, bring it down, but we know that 0 times anything, right? 2 times 0 is 0, 0 times 5 is still 0. That's a key point, and Mr. Largent nailed it. He graphed 3, 0. And then the last one, I won't show all the work, but hopefully you get this think 0 idea down. If we plug in a negative 2 for our x, we're going to get 0 in this parenthesis times, it doesn't matter what the rest of those are. So negative 2, 0 is going to be our other x-intercept. Hopefully you answer the question correctly from Monday, and that is, what is another word for x-intercepts? And you should have said roots, or you should have said zeros, because if you plug in that number, you get 0. So that's why it's called a 0, or it's called an x-intercept, or it's called a root. Kind of the way I view it as a root. Nobody told me this, I just came up with it. But a root is kind of like where something hits the ground. So if you imagine this is a graph or a tree, like where does it hit the ground? Like that's the root of it, right? The beginning of it. So that's kind of how I remember it in my brain. Now, Largent got these 4 points, nailed them, and then he kind of just drew this squiggly graph. And it also was correct, but we don't really have a reason as to why it was correct. So once we get these key points, I want you to think about something here. When Largent graphed these points, he had a couple down here, and he's got this one up here, and I believe that he did something like this. But could he also have had 3 points? And could he have gone like that? And that maybe looks a little bit different. When we had a couple of graphs that don't exactly look the same here, we need to figure out which one's going to be correct, and how do we do that, right? I'm trying to even think if there's another way I could do it. I'm trying to just get creative here with some art. What if I went like, That. Could that have been another graph? So we got kind of like an M graph going on. We got like a W graph going on, and then we've got like a N. I don't know, capital N. So we needed to figure out which one it actually is going to be. And the key out of these is what we do not see in the problem, but we've talked about, we learned last chapter, amplitude, stretch factor. What is the number out front? When it's not there, it is a 1. 1 times anything stays the same. So the stretch factor or the amplitude is a 1. What this 1 means is that the graph ends positive, right? It ends positive. So this stretch factor or this amplitude tells me how the graph ends. And how that ends is going positive. So all you need to know is it positive or negative? So this stretch factor, this amplitude, is telling you that it is a positive orientation. So we've got another new vocab today, which is orientation. Think about if you're out in the woods. I think there's something called orienteering, and that's how you navigate yourself through the woods. If you orient yourself, it's which way are you pointed, right? Hey, orient yourself, turn around, right? Direct yourself, right? Or if you are disoriented, you might have just gotten knocked down and came up and you're not sure which direction, which way is the right way. So we're looking for the right way here. Because the stretch factor is positive, it's a positive 1, you can imagine x times x times x is going to give you x cubed. That's positive x's, right? So there is no negatives on those x's. So we have positive orientation. The graph is going to end positive. So it's kind of weird. We don't really graph these left to right. You kind of go for that orientation at the end. We have a positive orientation. So this one is going to be out as an option. That one was going downwards. Both of these are ending up positive. So it's going to go through this root of 3. It's going to cross through. And then it's going to come up. And then I've got to go hit that y-intercept that Largent nailed up at 6. And then I got to come down for the rest of my graph. So it looks like this one is kind of what the option is. This one, it doesn't look like a W over here. So we've got this as our graph, right? So we had 3 roots because we had 3 x's. So we have 3 zeros, right? And we kind of have 3 pieces to our graph as well. We have this upward sloping piece, and then we have the downwards hill on the roller coaster, and then we've got an upwards piece right there. So we've got 3 pieces of the graph, 3 parts of the graph because we had 3 roots. So we're kind of seeing like 3 parts of like hills of that roller coaster, or 3 parts of how it's changing direction or orientation. So if you see 3 x's, your graph should be looking like it has 3 parts. It could be going up, down, up, or it could be the opposite. It could go down, up, and then down. This would be another 3rd degree problem, but this would have negative orientation because it ends negative. This over here has positive orientation because it ends positive. So we're going to take a look at a couple numbers out here that kind of change some things today, and how does that switch our graphs up. All right, everybody, so we got 6 problems that we're going to look at, and we're going to be trying to graph these by hand. So without Desmos, how can we sketch these graphs and hit some key points on each of them? The nice thing is that all of these are factored. We see these parentheses. These tell us our factors. They tell us our key points, our x-intercepts, also known as the roots, also known as our zeros. So we're going to take what we learned from Mr. Largent earlier, and we're going to connect that to make these graphs pretty straightforward. All right, so we're going to take a look at number 1 here. All right, I'm going to go ahead and quick sketch a graph. I'm not even going to mark it yet because we're going to use our zeros and our key points to help us out. So I always like to find the factored form, the x's, the roots, the zeros right away. So I'm going to skip on this too and get to that later. That's going to help me draw the graph, but I need the key points first. So -1 is going to be a 0. If you plug in -1 here, you're going to get 0. And 0 times anything will turn to 0. So when I plug in -1, here's -1. I'm going to get 0. So negative 1 comma 0 is going to be a point in x-intercept for this graph. I go to the next factor, and negative 4, if you plug that in, is going to give you 0. So negative 4, negative 1, 2, 3, 4. Negative 4 is going to be a 0. If you plug in negative 4, you're going to get 0. 0 times whatever this is, or whatever that is when you plugged in negative 4. And then we're going to plug in a 1 here. 1 minus 1 will get me to 0, and then 0 times all that other stuff will end up 0. So 1 is going into this as a positive 1, and that creates my 0. So just that easy. I mean, I can do all that math mentally, right? I don't have to set up an equation, right? So now I'm going to take a look at this stretch factor, or this amplitude, or this coefficient, this number that's out front. This is going to tell me a key piece of the graph, which is our vocab for the day, which is orientation, right? We're learning about the orientation. Which way does this graph go? Which direction does it go? And the key is that that's positive, so the graph is going to end positive. We learned this like when we graphed like 2x plus 1 when we were back in algebra. This number in front of the x's is positive, so that was a positive sloped line. The thing with polynomials is they're going to go multiple hills in multiple directions, but this positive orientation tells you how the graph ends. So that was a line, and a line is a polynomial. These are just more complex polynomials that have more x's in them. So this is a positive orientation, so the graph is going to end positive. So instead of going left to right, I'm just going to go to this last one. I'm going to end positive. And then I'm just going to trace it back and just kind of go through and hit all the points. I'm going to go down, I'm going to go up, and I'm just going to hit through all the rest of the points. There is one other key point that would help us out if we wanted to see how steep and tall and how low it goes, and that would be the y-intercept, right? So if I wanted to find the y-intercept, we will kind of learn this from Largent. We could basically just multiply all these numbers in here. What we're really doing is we're plugging in 0. When you plug in 0, you just get a 1. When you plug in 0, you get a 4. When you plug in 0, you get negative 1. And then you just multiply them all together. The thing is, we got to multiply by this stretch factor, by this amplitude. So basically, we're just going to do 2 times 1 times 4. That gives us 8. And 8 times negative 1 is negative 8. So this y-intercept right here would be at negative 8. Now, if I didn't mark anything, I might think that that's an 8 and that's an 8. Like, are these all going by 8? So we might want to mark, the x's are going by 1s, and the y is at negative 8. I could mark 1, 2, 3, 4, 5, 6, 7, 8 if I wanted to do that ahead of time. I'll try that on the second one. So we got an uphill, a downhill, and an uphill. There's 3. That's our third degree. We got 3 x's, so we should see 3 parts, and we see 3 of our x-intercepts, 3 of our roots right there. Cool, we're going to go ahead and take a look at number 2. On number 2, we've got a negative stretch factor and it's a decimal. Don't worry about it. That's the last thing that we're going to worry about. We're going to go ahead and sketch a graph. We're going to hit these key zeros, these key roots, these key x-intercepts. You can go in any order that you want. I'll go here. How do I make that a 0? A positive 4 for the x. 1, 2, 3, 4. There's my positive 4. If I look at this one, that's going to be a negative 3 that's going to take me to 0. So negative 1, 2, 3. If I plugged in negative 3 for x, it would give me 0. And x right here would be a positive 2, would lead me to 0. So point is going to be 2, comma 0. Let's go ahead and do what Largent did and find that y-intercept, right? If I multiply negative 4 times 3, that's negative 12. Negative 12 times negative 2, that's a positive 24. And then positive 24 times a half is back down to 12, and then there's a negative there. So negative 12 is my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I don't have to label the scale on all these. I know that that's just going by ones. We do want to take a look that this is a negative orientation. So the end of the graph is going to end negative. So if I go to this last point, the graph is going to end negative. Now we just almost trace it backwards and we just make sure we hit all the points, right? So this one's going to come through this point and then it's going to cross through that one. And now instead of just like looping right here, we have a key point. We have the y-intercept all the way down here. So I'm going to get a more accurate graph and go down through that one. And then I'm going to come back up and hit through our last root, hit through our last x-intercept. Cool, not too bad, hopefully. And now we're going to go ahead and do number 3. For number 3, we have a fraction for our stretch factor for our amplitude. Don't worry about it. It's going to be one of the last things that we do, right? It is a positive, so we know the graph's going to end positive. But I'm just going to go ahead and find these key points. These are all x plus something, so I'm going to need all my numbers on the negative side of my x's. So I'm going to stretch that out a little bit over there. Again, I can go in any order that I want. I'll just go this way and come back to the amplitude. So, and if I plugged in an x of -2, that would lead me to 0. If I plugged in an x of -5, that would lead me to 0. 3, 4, 5. If I plugged in a -8, so -6, 7, and -8, I've got my zeros, my x-intercepts, right? My roots. The stretch factor, the amplitude is positive. The number up front that's multiplying is positive, so it's going to go ahead and end positive. So this graph from the last point is going to end positive. If I want to see the y-intercept, remember, just do that little thing that Largent was talking about. Just multiply these, right? 2 times 5 is 10. 10 times 8 is 80. 80 times a tenth, that's just going to cancel that other 10 that's out there. So 80 times a tenth, or 80 divided by 10, is 8. So the y-intercept, if I want to be accurate, 1, 2, 3, 4, 5, 6, 7, 8. So we had that up arrow. There's proof that it was going up and needed to hit through that point. So the orientation, the stretch factor, the orientation was positive here. The amplitude was positive. So that graph should be going up and hitting that 8 at that spot. Again, all we did to do that was you're technically plugging in x of 0 right here and seeing what the y is. When you plug in 0, you just get 8. When you plug in 0, you get 5. You plug in 0, you get 2. So we're just multiplying 2 times 5 times 8 times 1/10. Now we just go back and make sure we hit the rest of the points on here. How far should I loop down? We're not worried about that. We're just trying to get the sketches of the graphs. We could talk about that. You could plug in -1, 2, 3. Plug in -3 into that equation and see how far it goes down. But we're just learning the sketch of the graph, so we just want to go through the root. We want to go through the x-intercept. We want to go through that 0. We got 1, 2, 3 parts to that graph. That's because we had 3 x's on there. Number 4, that is going to be the problem that you are going to describe. The question is, what does the graph of this, number 4, look like? And that's what your little homework check is. You might need to key into 5 and 6 because they have just this plain old x here, which number 4 has. So you're going to give me a quick little description. What does the graph of number 4 look like? You can tell me some key points. You can tell me the orientation. You can tell me how does it end, and so forth, right? So number 4 is for your homework check. Number 5, you're going to need it because it has that x just like that and something a little bit new, so pay attention. But we're going to do the same things that we did on all the other ones. All right, we'll go this way. We're going to start with the x here. If I had a -1, that would take me to 0. So x of -1 is going to be a 0. Right here, if my x was 3, 3 minus 3 is going to be 0. So if I plugged in a 3, that would give me 0. 1, 2, 3 is your 0. 3, 0. Let me ask this question, see if you can answer it in the next couple seconds. What number can you plug in here to get 0? Go back to this one. What number did you need to plug in to get 0? 3. 3 minus 3 would get you to 0. So what number do you need to plug in here to get 0? It's just 0. So your other x is 0 right here, 0, 0. If you plug in 0, you're going to get 0. Right? Plug in 0, 0 times all that other stuff is still going to be 0. So hopefully that helps you when you go back and tell me a couple key points in what that graph looks like on number 4. So we've got our 3 roots, we've got our 3 x-intercepts, we've got our 3 zeros for the problem. Let's go ahead and find the y-intercept before I start drawing this, right? So if I would plug in 0 into all of this, I would have -2 times 1, which is -2. -2 times -3 is 6. 6 times, it might help to imagine this last one as like x plus 0, right? Or x minus 0. And you go, wait a second, what's -2 times 1 times -3 times 0? If you were to plug in 0 for x here, you would get 0, and take a look. This point is both an x-intercept and a y-intercept, right? So it might help for you to, when you see this x right here, write it as x plus 0 if it helps you understand what the problem is talking about, what the graph is going to look like. So we've got our 3 x-intercepts, and we've got a point that hits our y. That's our y-intercept already. Since our stretch factor, our amplitude, our coefficient is negative, we're going to have a negative orientation, which means the graph ends negative. I'll go ahead and write that down. Negative orientation. So that's how I would describe. The graph ends negative, there's negative orientation. So I'm just going to go backwards and hit through all these points. Just loop there. This is just going to be a small little loop to hit this one. And then I go there. So it's going 1, 2, 3. There are 3 parts because there's 3 x's on there. Cool. You might notice that all these today have 3 x's. I'm just trying to keep it consistent, keep it easy, see if we can get the shape of the graph. We're going to deal with some 4 x's next week, some 5 x's. Are there 2 x's? Yeah, we've done those. Those are called parabolas, right? Cool. Number 6. You see one more new thing in number 6 to finish up. And that is the fact that one of our zeros has a squared on it. We did talk about this in the last video, but we're just going to combine it with today's lesson and put it all together. All right? Take a look at your x or parentheses. -3 would be a 0. We just learned that 0 is going to give us a 0 on that one. And we only have 2 points. It's weird to think about what that graph might look like, but let's just do the same thing we've been doing on all the other ones, right? We come back to this point. We know that the half is going to be our positive orientation. The graph is going to end positive, right? So as I come back through this, it looks like we might just have a parabola, which is weird because we have x squared times another x, which is x to the 3rd. It should look like 1, 2, 3 if it's positive orientation. Or it should look like 1, 2, 3 if it was negative orientation. And it is a positive, so it should look something like this right here. Shouldn't be a negative orientation. Should look like a positive orientation, but that's not what this looks like. Remember from the last lesson that if we ever have a squared, that is a double root. And that's the one that bounces off of the x-axis. So I could rewrite this problem just by writing the x plus 3 twice. It is a double root. The x plus 3 tells me it's going to get to this -3, and at this -3, it is not going to go through the point. It's not going to go through the -3. A double root is going to bounce off the x-axis. So I'm coming backwards, but because this is a double root, it's going to bounce off of it and come down. So there's a parabola that's happening on that -3. There's a parabola happening on that -3, and then it goes and hits through the 0 for the last one. And that is our 1, 2, and our 3, which is our 3 x's, or x squared, and then another x multiplied would be x to the 3rd. So we should have a positive orientation, should have 3 parts to our graph. So hopefully that gives you everything that you need to go back and do number 4. The question is, describe what that graph looks like. All right, have a wonderful day. Check in with a friend. See what they're gonna type in. Like, use this time to connect with each other. It's fine. Like, you're just getting 1 point, so it's not copying or cheating. Like, talk with your friends and come up with an answer together, and let them know that you're thinking of them. All right, have a good one. Peace.